Welcome to the NPTEL online certification course. The title of this course is Control and Tuning Method in Switch Mode Power Converter. If we look at transportation and electrification, communication technology, consumer electronics, healthcare, space application, robotics, renewable energy, everywhere we will find power electronics, and this is used for energy efficient power conversion, and this is the unified theme across many domains which include nonlinear dynamics, circuit system, control system, then physics, electronics, electromagnetics and so on. So, this is an interdisciplinary research and development activity, and the modern trends of power electronics. The power electronics is going through a transformational change where we are going to witness increasing use of wide bandgap devices, in which we are primarily trying to operate at a higher switching frequency and also to achieve higher efficiency, so that the size of the converter can be reduced, thermal overhead can be reduced. Another important parameter is to achieve high performance for various application. We need to meet stringent performance requirement, and because we are trying to operate at a higher switching frequency, so we have a time constraint. So, we need to use a smaller resource yet to achieve high performance. So, we need to achieve high throughput. Switching converters are also source of electromagnetic interference. So, we need to reduce EMI as well as harmonics, and this is particularly very important for automotive and space application, and there are many other applications. In this course, we are going to primarily focus on DC power conversion system, in which there is a DC source and we are going to consider DC load. There can be one or more multiple DC load. The load voltage and load current can be different from the source. We need that means we need a DC power processing element, which is a DC-DC converter. The source voltage can vary, the load current can vary, as well as some load current can vary in step transient. Sometimes the load voltage can also vary, particularly for dynamic voltage scaling application. So, the primary objective of the DC-DC converter is to achieve tight voltage regulation. In some cases, we need to achieve like a high current regulation, for example, the constant current, battery charging, LED driving. We also want to achieve high efficiency over a wide range of load current and input voltage, and we also want to achieve very fast transient performance, and we want to reduce the size of the converter. So, we want to also target for high power density, and at the same time we need to ensure stable periodic behavior, so that the ripple can be predicted. Why is this course? This course is somewhat different from conventional switch mode power conversion converter, in which in this course I am primarily first I want to give a glimpse of what are the present and future performance and efficiency challenges. I also want to introduce a wider range of modulation and control technique, and in majority of the commercial product using small signal based PWM control, and in this course we are going to consider wider range of modulation and control. We are going to identify the performance limit in traditional small signal based PWM control, and also we are going to see the switching dynamics in order to achieve performance beyond the physical limit, system physical limit, and we need to incorporate such switching dynamics into our control as well as our tuning method. I also want to introduce large signal based control and design method, and I also want to show how such large signal based control can be used to achieve fastest transient performance, such as time optimal control, and also to identify what are the current and voltage limits, and under such limit what could be the achievable performance, and also to achieve high efficiency. So, I am just showing a step up DC-DC converter, which is a boost converter, and where I am using 8 volt input and 12 volt output. The converter is going through load transient and step load transient, and here I am showing the experimental result using current mode control, which is designed using small signal based model, which is traditionally used in commercial product, and this performance limitation is due to the right of plane 0, the bandwidth limit is due to the right of plane 0. But if we use a large signal based control as well as tuning method, we can improve the performance by 8 to 10 times. So, in this course we are going to see the increasing use of such large signal based control technique to further improve performance. This course is designed for 12 weeks, And first I want to introduce briefly the switch mode power converter, primarily non-isolated converter, but many of these techniques are also applicable for isolated converter as well. Then I want to touch upon different fixed frequency and variable frequency modulation technique. I also want to introduce various feedback and feed forward control method, and I also want to give an overview of modeling and analysis techniques, and also I will discuss about small signal modeling and frequency response analysis. I will also summarize the small signal based design and tuning method, and then I will also show what are the limitation of this small signal based design, and then what is the need for large signal based modeling and control, and then I will show you large signal based tuning method and how to formulate the critical performance limit. So, who can attend this course? This course is designed for MTech and PhD student working in the area of power electronics, power management as well as power system and control system. Faculty members working in the area of modeling and control of power electronics will get benefited. Final year BTech student in electrical and electronics engineering can attend, and also industry practitioner with at least undergraduate degree in electrical and electronics should get benefited. So, with this I want to encourage to register for this course. Thank you very much.